Hi there, and welcome to this photoluminescence quantum yield tutorial. Today, I'm going to show you how to measure the quantum yield of solid samples in the QYPro integrating sphere on an FLS 1000. I've already connected the integrating sphere, but if you want to see the setup of this, it's on our YouTube channel. Today's sample is an inorganic phosphor powder which I have prepared earlier. You might notice that I have placed a quartz cap on our blank. This is because we need to try and match the scattering properties of our sample as best as possible. Our sample, being a powder, is liable to contaminate the integrating sphere if we do not cap it and seal it. So for this instance, our sample has a quartz cap, so our blank also has a quartz cap. Now that the blank is in the integrating sphere, we can start selecting our measurement parameters. The first one I will select is the excitation wavelength. To do this, we need to understand the absorbance and emission properties of our sample. On screen, I have the absorbance and emission spectrum. To select an appropriate excitation wavelength, we must choose one which does not overlap with the emission of the sample. In this case, I will choose an excitation wavelength of 440 nanometers. Now that I have selected the excitation wavelength, we will launch the signal rate screen and begin to pick the rest of our measurement parameters. The first thing I will do is check that the detector light path is set to that of our integrating sphere. This is important as it ensures that the appropriate emission correction file will be applied to our data during recording. Next, I will set the excitation and emission wavelengths to 440 nanometers, as discussed earlier. I will then close our emission bandwidth to prevent detector saturation. When recording quantum yield experiments, we recommend a wide excitation bandwidth and a narrow emission bandwidth. The wide excitation bandwidth is important to ensure that our excitation peak can be reliably integrated, and a narrow emission bandwidth is used to prevent saturation. I will now begin to slowly open the emission bandwidth. I have now set all of the settings in the signal rate screen, and I can move on to the measurement parameters. To record the data, we will launch our emission scan dialog. This is done by clicking on Lambda, or spectral measurements, and emission scan. Firstly, I will ensure that the correction settings are appropriate. In this instance, we want to subtract background, use excitation correction, and apply our emission correction. I will then set the scan range. The scan from is set to 420 nanometers, which is 20 nanometers before our excitation wavelength. And the scan to range is set to 780 nanometers, roughly 20 nanometers after the end of our sample's emission. Next, I will set the step size. An appropriate step size is equal to or less than 10% of our widest bandwidth. I can now start this measurement. Now that our measurement of the blank is finished, we should mount the sample in the integrating sphere. I am mounting the sample in the direct position of the QYPro. This is underneath the mirror. Our excitation beam comes through here, hits the mirror, and is directed down onto the sample. We're now ready to measure our sample. It's important that both our sample and blank are measured with identical parameters. This can be ensured by selecting our blank as the active window in Fluoracle and using the Rerun Measurement button on our toolbar. This will launch the emission scan dialog with identical parameters, and I can hit Start. Now that our measurements are finished, we can determine the quantum yield using Fluoracle's Quantum Yield Wizard. To do so, I need to join both scans into one window, and I can now hit PLQY on the toolbar to launch the wizard. Firstly, I will be asked for the general settings, which in this instance was a solid sample measured direct only. I click OK and the quantum yield wizard launches. We can see that both the blank and the sample have been assigned correctly, so I just need to hit validate. Upon hitting validate, the scatter range is estimated by the quantum yield wizard. This looks good to me, so I will click and drag on the selected scans window to set the emission range. I can now hit calculate. The quantum yield has been determined to be 84.07%, approximately 84%. This was expected for a bright inorganic phosphor powder such as today's sample. I hope you found this tutorial useful. If you have any questions, comment below and we'll get back to you. To stay up to date, subscribe, and thank you for watching.